up, they can just watch the recording. All right, so I don't want to take too much time here. I just want to finish this one up, and then there's one other really quick one I want to do, and that's it. Then I'll let you go. So we wanted to finish up this example we were looking at here, and there's not much left to do, right? We came up. The hard part was getting this set up. So we got the equation. We got the volume function set up for our inscribed right circular cone. Now all we have to do is just take some derivatives and make our table, right? So we took the first derivative. No, we didn't. This isn't a derivative. This is just our function, right? So we've got our volume function. I thought that was a derivative for a second. Then we've got our first derivative. We'll just leave that pi thirds out front and just differentiate term by term. And we're going to get a 52h minus 3h squared. And so v prime is going to equal 0 when this term in here is equal to 0, right? This factor is equal to 0. So when 52h minus 3h squared equals 0, we can factor that. I could factor out an h, and I'm left with 52 minus 3h equals 0. So we get two critical numbers then. One is h equals 0, which makes no sense at all, right? That's obviously got to be some kind of a minimum or something. That one we're not going to worry about. And the other one is when h equals 52 thirds, which is, what's that going to be? Roughly, that's about 17.3. Okay. Yeah, 17.3-ish. And then we might as well take a second derivative because it's so easy to do. And we just get pi thirds times 52 minus 6h. So we can see that if we're plugging in 52 thirds, 17 point something, that's going to give us a negative second derivative. So it's negative. And then our table, can I squeeze the table in down here? Maybe I can. I'll try. Our domain, we said, wasn't it 13 to 26? And we had one critical number at 52 thirds, which is in that domain. 0 of the first derivative, negative of the second derivative, and so there's our maximum for volume. And I think they were asking for find the volume. Okay, so that's all they asked for. They didn't want dimensions. If they want dimensions, we've got h. I could just plug that in right there to find r if I need to. But otherwise, if I want the volume, I would just use this function right there, right? I've got it as a function of a single variable right there, so I could just plug in 52 thirds, and I won't even go through the hassle. I could plug 52 thirds in there and get some number, and that would be my answer. Okay? Questions? Is that all good? No questions? You guys can hear me, right? Yeah. Okay, all right, good. Okay. So then here's the other one I thought maybe we'd just take a quick look at. Just one more econ problem. Maximum profit. So assume that the amount of money deposited in a bank is proportional to the square of the interest rate the bank pays on the money. Furthermore, the bank can reinvest this money at 12%. Find the interest rate the bank should pay to maximize profit. Okay, so you understand what they mean by that, right? If when you deposit your money in a bank, how does the bank make money? Well, the bank it reinvests that money, and it makes a return on the money that it invests. It invests in all kinds of things. The bank makes an average of 12% return on its investments. And so it's going to, but what's your incentive for putting your money in the bank? Well, it's safe for one thing, but the other thing is you're going to get back some minimal interest rate. You're going to make a little bit of money, a little bit of interest on your money. So the amount of money that gets deposited is proportional to the square of the interest rate, because people are going to be more inclined, there's more of an incentive for them to invest their money in your bank if you're paying a higher interest rate, right? So we got to figure out what's the optimum interest rate given these parameters to maximize profit. So we said earlier, right, that profit is just revenue minus cost. So we got to come up with a revenue function, right? We know, remind you about that. So we know profit equals revenue minus cost. So what's our revenue function going to look like? The revenue function is the amount of money that we've got coming in. Well, the bank is making money based on the amount that's deposited and its interest rate, right? So R is equal to 0.12%, or sorry, 12%, which is 0.12 times the amount of money that's deposited in the bank. That's the amount of interest it's making, right? Okay, so there's, okay, cost. The bank is paying out.
You're cutting out a lot.
Oh, I am?
Yeah.
I wonder why that is.
I think it's your mic plugging out again.
Oh, great. This is my second mic. Does that sound okay now?
Yeah.
I wonder if it's, well, let me try this again. Okay, try that one more time. So that sounds okay now?
Yeah.
Okay, so there's my revenue. 12% times the amount of money that the bank has access to. The cost, what I'm paying out, is going to be I times the amount of money invested, right? Does that make sense? Okay, so revenues, am I doing that right? Oh, hang on. No, I didn't do something right. I forgot something really important here. The amount of money deposited in the bank is proportional to the square of the interest rate. Right, so we'll get back to that. The cost is going to be I times X. Okay, but there's two unknowns there, right? There's the interest rate that the bank is paying and the amount of money that's deposited. So my profit function then looks like 0.12x minus ix, but I've got two variables there, so I need another equation, right? I've got to come up with an equation that relates I and x, where I is the interest rate that the bank is paying. Okay, let me pause right there though for a second. Is that clear? Any questions? Don't be bashful. Any questions on this so far? Give me a no in chat if there's no questions. Okay, fair enough. So then that's where this little bit comes in, right? We've got the statement up here. The amount of money deposited in a bank is proportional to the square of the interest rate the bank pays on the money. Okay, so that means that X is proportional to I squared, right? X is proportional to I squared. Well, the way I would write that as an equation is X equals K I squared, okay? So we can make that substitution then. I could substitute, like I could, for example, I could solve that. Well, it's already solved for X. So I'm going to make that substitution up here in my profit equation. Okay, notice in my profit equation, I could have factored out an X here and written that as 0.12 minus I times X. And I'll make that substitution. And I get 0.12 minus I times Ki squared. Okay? Okay? So now this is P of X. Okay. So I could just distribute, I could pull the K out front. And distribute the I squared, and I get 0.12 I squared minus I cubed. What would my domain be? Oh, that's P of I, not P of X, too. I got to fix that. So if I is the interest rate, what would my domain be here?
I'm super lost.
Okay, ask a question.
Wait. Okay, so P equals 0.12x minus ix to the next step. I just completely lost track.
From this step right here?
Yes.
Okay, so all I did there, right, there are two variables there. We've got profit as a function of interest rate, which is going to vary, and the number of the dollars invested, number of money invested, amount of money invested. Those are both things that vary, right? So I had to make a substitution. The substitution comes from this statement right here. This is the statement underlined in orange is the statement that's going to relate I and X so that I can eliminate one of those variables, right? They told us that the amount of money invested, which is X, right, is proportional to the square of the interest paid by the bank, which is I. Okay, see, that's defined for us up here, right? Are you guys seeing that? Like, can you see where I'm pointing my little thing here? Doesn't show up, does it? That's too bad. So this is the equation we get then. When we have a proportionality, we have to introduce this constant of proportionality to make it an equation. We know that if x is proportional to I squared, then x is equal to some constant times I squared. Okay? That's the substitution we can make right here. Okay, do you see, Caleb, what that does for us then? Then we end up substituting for x, and so now my profit function no longer has two inputs. It only has one input variable, which is I.
So the thing I'm confused on, so you have, you just took out an x from share x, okay. I got it.
Oh, yeah, okay. I got you. To get from here to here, right, I just factored an x out, exactly. To get from this step down to this step. Right, this guy up here down to this guy down there. Okay, does that make sense?
Yes.
Okay. So now we just want to know, we've got profit as a function of the single variable I, of the interest rate paid by the bank, which is great because that's what we're trying to set. We want to set the interest rate to maximize profit, right? Okay, so what should our domain be then? What should the domain be? What are the values of I that we should consider when we're trying to maximize profit?
0 to 0.12.
Okay, so yeah, we could say that. We could say 0, and you might see that obviously it wouldn't make any sense to pay more interest than what the bank is is getting back on its investment, right? So you might stop that at 0.12. Even if you didn't, even if you said infinity, that's going to work too, because you're just, you're only going to get a maximum for values that are obviously going to be below 0.12, but the math gods will take care of that. So if you didn't see, it wouldn't be the biggest crime in the world if you didn't see that logically probably should only be 12% as your maximum, right? Either way. So now we would just differentiate and make our table. Now we're in math mode, just in calculus mode. So P prime of I, we just leave that constant out front, right? And then we get 0.24 when I bring the 2 down, 0.24I minus 3I squared. P double prime of I would just be K times, God, man, this thing's not writing, 0.24 minus 6I. And here's where we can find our critical numbers. So we would know that P prime equals 0 when 0.24I minus 3I squared equals 0. I could factor out, let's just factor out I. And so I get the critical numbers I equals 0, which isn't gonna obviously be probably our answer, but that's one critical number. Or I equals what, 0.08 if I set this equal to 0 and solve. Okay, and then we could just make our table, and that should do it. So we went from 0, and we could include 0. That could be a bracket. There's no reason not to. In our substitution equation, there's nothing on the bottom. So we could make that a bracket. That's okay. We had 2 critical numbers at 0 and at 0.08. These are both zeros of the first derivative. What about the second derivative? P double prime of 0 is going to be positive. P double prime of 0.08 is going to be negative, isn't it? 0.24 minus 6 times 0.08 is negative. So then we can see here that this is a maximum and this is a minimum, and we want the maximum for profit, so that's it. We set our interest rate at 8%, and that's going to be the best one for us. Okay, questions? Kirsten, Andy, you two good? Okay. All right. I'm going to let you go enjoy the sunshine then. You guys will have Friday. I am going to be gone Friday for sure. So you'll have Friday in class to just maybe work together on some of this stuff. And if you're not done with that test, just have it done by the end of the week, because we're going to be doing, hate to drop this bomb on you, but we're going to be doing a test on optimization next week. And I'll leave it up to you guys, but my inclination would be, again, to just probably do an at-home test, but you guys can decide on that on Monday. So, all right, have a great day. I will see you later.